at this second piece, I do want you to fold it so you can see the top and the bottom. What do you notice about graph A? It's a bunch of dots. It's a scatter plot. So let me ask you, is this continuous like the other graphs we looked at? No. Does anyone remember what it's called when it's just dots? It is. Someone said it. Good. Discrete. When it is only dots, it is what we call discrete data. And that means we will use a list for domain and range. So because this is not continuous, we cannot use inequalities. It is only specific points, therefore we will make a list of the points, yes. Now you have a table down here. I'm actually going to write my table next to the graph so I don't have to keep going up and down. But I want us to make a table of these coordinates really quick so we can find that domain and range. So let's look. This first coordinate is at -4, -3. Does everyone see that, where I got those numbers? Then we're at -3, -1, -2, +2, -1, and -2. Then I'm at 1, 0. And I'm at 2, 4, and finally I'm at 4, 1. Does everyone understand where those points come from? You can either write them on the table on that second page, or you can just make it here. I don't care where you do it. I just want you to see what's happening. Yes. If you're using this one down here, if you don't have those coordinates, you don't fill in the box. Okay? So here's the thing about the table. You can see a lot of things from it. Is this a function? Yes. Okay, I want you to be aware. Domain and range can be found on a function or a non-function. Okay? When we look at this X column is our domain, and this Y column is our range. Okay, so remember I told you we're going to list them? This is super hard, let me tell you. You're going to be like, what? So here's my second page. I'm just going to fold it so I can see where it says domain and range. So we're going to list them. So domain, we always use this little, it's called a brace. It's like a little squiggle line. If you don't know how to make that brace like that, then just draw a squiggle. This is saying that it is a set of numbers. So we have, what are our X values? -4, -3, -2, -1, 1, 2, and 4. That is our domain. And it's just a list because they're individual coordinates. We cannot use inequalities because that implies that it is including the fractions, the decimals, the square roots, and all of those imaginary numbers within those spaces. These are just specific spots, so we cannot use an inequality. All right, so the range, again, it's a set of numbers, so we have a brace, -3, -1, 2, -2, 0, 4, and 1. These are just straight from my table right here. Do you see that? Do you see the difference between continuous and discrete? Do you think you can try this? Now, if you don't want to use this page down here with the tables and the domain and range, that's fine. You can just write next to the graphs like we've been doing, which is perfectly fine. I am going to ask you to try, remember it is a try assignment, B, C, and D. Now, I do want you to look at C really quick. I do want you to draw your function window like we've been drawing with your highlighter. I want you to look right here at C. Notice that when I draw my window around C, it looks like I touched it, but notice that this graph is not touching that -2. And also notice that we are going past the y-axis. So I'm going to have you write, we're going to guesstimate here at 0.25. 0.25. So when you write your domain and range, you have a boundary number. Okay? Pretend my line touched that. Let me make it a little bit fatter.
My line just curves.
Your line is perfect?
Not perfect.
It curves. So again, we're going to call this 0.25. Okay? So I want you to try to write the domain and range for B, C, and D, and then tomorrow we're going to talk about that and we're going to elaborate.